Hey there, hello everyone. I'm Prithviraj HM from the CSAI department. So today my topic is on Karatsuba algorithm. So I might be wondering what does this algorithm do? So this algorithm is basically used for fast multiplication. So that this algorithm uses a technique called as divide and conquer technique approach for multiplying a large amount of numbers. So let's get started with this and know more about this topic. So then we are having the limitations of traditional multiplication. So the limitations of traditional multiplication is as follows. So traditional multiplication methods like the standard algorithm can become very computational expensive, especially when dealing with some kind of large number of or large numbers. So we'll head with a different concepts like different problems such kind as time complexity. So the time complexity for this can be like O power n square, and it can also be like a resource consumption. So when you are using this, so the resource consumption, the time complexity solely depends on the amount or the quantity of input we have given to the program. So here as you can see, for the time complexity, if you are having a time log complexity as O n square, so which means that the time required to multiply a 2-digit number grows quadratically with the number of digits. Then we have the resource consumption. So this means that for a very large numbers, the computational resource required for multiplication can become significant. So this is directly seeing that if you are having a very large sum of numbers or a very huge quantity of numbers, then you will be resulting in an increase of the resource consumption. So a computer will have to wait a lot of time for the availability of all the resources it needs. So then head to our next topic. So what is divide and conquer approach? So what are the approach we follow in this Karatsuba algorithm? So this Karatsuba algorithm, we can break down the problem of multiplying large number into smaller sub problems, so that can be solved recursively. So it can be, the first thing is divide, then we do the conquering, then we do the combine. So let's understand all the three concepts one by one. So are in the dividing stage. So the input number are divided into two parts of roughly equal size. So you can imagine I have a input of something like so called 10. This 10 can be divided equally into two equal parts. So you can divide like 5 and 5. So you will be having one part 5 and another part 5, so which are divided equally. Then we have the conquer technique. So in the conquer, the subproblems are recursively solved using the Karatsuba algorithm itself. Then we have combining. So in combine, what we do, the result from the subproblems are combined to produce the final product. So all these operations will be combined in the final stage. Then let us understand about the Karatsuba algorithm principle. So going through this, the algorithm leverages the fact that only 3 multiplications are needed to compute the product of 2 large numbers rather than 4 as the standard algorithm. So for example, you can see we have 3 different equations. So the first number, what you can see, x a star 10 power m plus b. So this first number is represented as the sum of 2 parts. Then we have the second one, that is the second number is also like representing as the sum of 2 parts. So then we are having the final equation, that is the product is calculated using 3 multiplications and some addition and subtractions. So this is what we are doing in the Karatsuba algorithm principle, and this is what it is basically about. So then let's have a look on the advantages of the Karatsuba algorithm. So the Karatsuba algorithm offers something like a significant improvements in terms of computational efficiency compared to a traditional multiplication, what you can see. So it offers a faster multiplication, it gives a reduced resource consumption and improved scalability. So let's understand all the 3 topics in depth. So now faster multiplication. So it has a lower time complexity than the standard algorithm, so making it faster for large numbers. Then we have reduced resource consumption. The algorithm uses fewer operations, which translates to less computational resources, and it also offers improved scalability. So the efficiency of the algorithm increases the size of the input as the number of it grows. Then we have complexity analysis of the algorithm. So coming to the complexity analysis of the algorithm, so the Karatsuba algorithm has a time complexity of O n log 2 of 3, so which is significantly better than the O n square complexity of the standard algorithm. So the algorithm time complexity and the standard multiplication of it is O n square. Then the Karatsuba algorithm, according to the equation, will be O n log 2 of 3. Then let us have a look on the applications of the real world examples. So the applications of the real world examples can be like the Karatsuba algorithm has something like numerous applications in the computer science fields. So it can be used in cryptography, even in your computer algebra system, and even in scientific computing. So when it comes to cryptography, I think it can be used for making some cryptographic algorithms, something like an RSA, so which rely on some larger multiplication techniques. Then we also have computer algebra system, so it is used in a symbolic computation, so where it is important to perform efficient arithmetic operations. Then you also have something like a scientific computing. So this algorithm is used in various scientific applications that involve some high precision calculations, what you can say. So that's it guys, that's it for this video. Thank you for watching. Please hit a like, make sure you subscribe to the video. Thank you guys. I see you in the next video. Bye.